All right, Unit 6, Extra Practice 1. We're going to do more complex solving equations with negative numbers. So I added this lesson in because there wasn't enough for it. So I can use the idea of doing the same thing on each side to solve equations that have negative numbers or solutions. All right, so we're going to start by solving our equations. Depending on how the class is going will depend on whether we're drawing diagrams or not. So I'm going to solve these in a standard way or the traditional way, and then if you're in class, you will have seen the diagrams with it as needed. So we're going to do the distributive property first. So I have 5n, and then 5 times a negative 4 is going to be a negative 20 equals negative 60. So I have to zero out first, so I'm going to add 20 to each side. So a negative and a positive 20 are going to zero out, and I'm left with 5n. My signs are different, so I have to subtract, so I get 40, and I take the sign of the larger absolute value. Now I want to find for just one n, so I'm going to divide by 5. So 5 divided by 5 leaves me with 1n, and then 40 divided by 5 is 8. The signs are different, so it's going to be a negative 8. Same thing here. I'm adding a negative 8, so to zero out, I'm going to add a positive 8. All right, my signs are the same, so I'm going to add, and I get 33. This zeroes out, and I have a negative 3t. Now, if I multiply by a negative 3t, I have to divide by a negative 3t, because I just want to know what it is for just one. So I'm trying to get that t isolated or by itself. So t equals negative 11. Because the signs are different, the sign of my answer is going to be different. All right, I'm adding a negative 11, so the opposite would be to add a positive 11. I have a zero pair, so I'm left with 25x equals, and then my signs are different here, so I have to subtract and take the sign of the larger absolute value. So now I have 25 x's. I want to know what it is for just one x. So I'm going to split it into 25 groups. And I'm left with x equals a negative 3. A positive and a negative, when the signs are different, the sign is going to be negative when I'm dividing. For the next one, now I'm adding in decimals. So I'm going to use the distributive property. So 3/10 x. And then I get plus 2.4, and if you want to know why, it's 0.3 times 8, so that gives me 24, and I have one number behind the decimal in my problem, one number behind the decimal in my solution. All right, so I'm going to zero out first, so I'm going to subtract that 2.4 on each side, and I'm left with 3 equals 3/10 x. Now I want to figure out what it is for just one x, so I'm going to divide by 3/10 on each side. So x equals, I want to say 10, but just let's double check because my math's been a little shoddy today. Yep, 10. And it's positive because both numbers are positive. All right, the next one, now we've got some negatives. So a negative times a positive is going to give me a negative 10x. A negative times a negative is going to give me a positive 17. 10 times 1.7 is 17. A negative times a negative is a positive. Equals negative 3. I'm going to zero out first. So a positive 17 and a negative 17 make a zero pair. So I have negative 10x equals, my signs are the same, so I'm going to add, and I get negative 20. All right, so I want to get x by itself, so I'm going to divide by negative 10 on each side. Negative 10 divided by negative 10 is going to leave me with 1, and 20 divided by 10 is 2. My signs are the same, so it's going to be a positive 2. All right, 2,000 times x is going to be 2,000x. 2,000 times 3/100. So I'm using my calculator. I get 60, and it's a negative 60, equals 6,000. So I have to zero out, so I'm going to add 60 to each side. Negative 60 and positive 60 make a zero pair. Then I have 2,000 x's. I only want one x, so I'm going to divide by 2,000 on each side of my equal sign. So 6,060 divided by 2,000 leaves me with 3.03. And I know my answer is positive because a positive divided by positive is a positive. Signs are the same. It's going to be positive. Okay, distributive property again. I've got 2x. And then 2 times 1.25 is 2.5. So I'm going to zero out. So I'm left with 2x equals 1. So now I'm going to divide by 2 on each side because I want to figure out what just 1x is going to be. It's going to be 1/2 or 0.5 if you used your calculator. Next one. 1/4 times 4 is actually 1. And 1/4 times x is 1/4 x equals 4/3. Now I'm going to subtract 1 on each side. So I want to zero out. So I'm left with 1/4 x. Now 4/3 is actually 1 1/3 because 3 goes into 4 one time with 1/3 left over. So 1/3 minus 1 leaves me with 1/3. Okay, if I multiply by 1/4, I'm going to divide by 1/4 on each side. Now, just because I've started doing equations doesn't mean that I stop doing keep, change, flip. So I have 1/3 times 4 over 1. So I'm left with 4/3 or 1.3 repeating. All right, so now you're at your cool down. I need you to go ahead and solve each of my equations that I've given you here. Make sure you either draw out your hanger diagram or your tape diagram, or you just solve it traditionally. It doesn't make any difference to me. Complete and submit your keynote, and then if you need extra practice, the links are in Canvas for Khan Academy. Mr. Morgan does a help video. You can email a study buddy, or go ahead and set up an appointment on Calendly. I do appointments on Monday, Tuesday, and Wednesday. I hope you have a great rest of your day.